Hey everybody, today we are going to solve radical equations and inequalities. So make sure you have your notebooks open to a new page, and here we go. Our first involves a radical sign. Now when you have a variable underneath a radical, it represents a radical expression. When you have an equation involving a radical expression, we have a radical equation. So the first step is to make sure we have our radical expression isolated on one side of the equation. The next thing we'll do is raise both sides to the second power in order to isolate or actually cancel our radical symbol. So whatever we do to one side of the equation, we know we have to do to the other. Now that we've done this, the radical is now canceled and we get 4x plus 1 equals 9. The next thing we do is just solve our equation the way we normally would any old equation. Let's isolate our variable by subtracting 1 from both sides first. We end up with 4x equals 8. Then we divide both sides by 4. And our resulting solution is x equals 2. Now what we like to do is make sure that our solution satisfies the original equation. So let's actually check what the solution should be. Let's now plug 2 in for x in our equation. So again, let's start off with the original equation we were given, which was the square root of 4, in this case, plugging 2 in for x, plus 1, set equal to 3. Remember, we're verifying whether or not this is a true statement. So really, this part right here is a question mark. We're going to verify that the left side is in fact equal to 3. So when I simplify the expression, I end up with 4 times 2, which is 8, plus 1. Again, is this equal to 3? The square root of 9 is certainly equal to 3. Therefore, this is a true statement, and our solution of 2 works. Now let's look at another example. Example 2 today. Say you're given a radical equation, and your radical is not all by itself on one side of the equation. What we need to do is isolate this by putting all the other junk over on the other side. So let's get rid of this negative 1 that's dangling out here. I'm going to add 1 to both sides, and we now have the radical portion of our equation isolated on one side. Then what we do is raise both sides to the second power in order to isolate the radical. So then, on the left side of the equation, I end up with y minus 2 equals 6 squared, which we know is 36. Let's add 2 to both sides, and we end up with y equals 38. Again, let's check and verify that it actually works. So here's my check. Let's make sure that when I plug 38 in for y, we end up with a true statement. Now when I do a checking process, I don't want to change the original equation. I want to plug my value in to make sure the left side is equal to the right side. So let's tackle this. 38 minus 2 is 36, then minus the 1. The square root of 36 is 6. And when you subtract 1 from 6, we sure do end up with 5. So again, since we get a true statement as a result of plugging 38 in for x right here, we know that our variable y is equal to 38 is our solution. Now let's look at another example. Say we have the radical equation given here, number 3, as the square root of x minus 12 equals 2 minus the square root of x. In a case like this, we have radicals on both sides of the equation. So what we're going to have to do in this case is raise both sides to the second power now, because we can't isolate just one radical on both sides of the equation. So what we do is we raise both sides to the second power, and we will at least eliminate one radical in this step. But remember, I'm going to wrap parentheses around everything on both sides of the equation in order for this to work. Whatever I do to one side of the equation, I have to do to the other entire side of the equation. So what we have on the left side is canceling of the radical. I get x minus 12. On the right side, however, we have a binomial. We have 2 minus the square root of x. So when I square this, we treat it like foiling a binomial. So I'm going to rewrite it as 2 minus the square root of x times 2 minus the square root of x. And we know what we do here, guys. We FOIL. So I'm going to leave my x minus 12 over on the left side. Let's FOIL it out on the right side. 2 times 2 is 4. The outer product is negative 2 root x. The inner product is, again, negative 2 root x. And then finally, multiplying the last two terms together, the negative root x and the negative root x, I end up with positive x, since the square root of x times the square root of x is equal to x squared. When you take the square root of x squared, that gives us x. So now that we've FOILed the right side of the equation, let's combine like terms. Notice that I have 2 radical terms, the negative 2 root x and the negative 2 root x. I can go ahead and combine those two together. So I end up with x minus 12 equals 4 minus 4 root x plus x. So it looks like we did not get rid of the radical on the right side. So what we'll do is put all of our terms over to the left side of the equation and isolate our radical, and then square both sides again to get rid of the radical. So I'm going to subtract 4 from both sides to get rid of the value 4 on the right side. I'm going to subtract x from the right side, which conveniently cancels on the left side. That may not always happen for us, but at least it does in this case. Now let's combine the negative 12 and the negative 4 to get negative 16. And on the right side, I have negative 4 root x. Now, we want to isolate this radical all by itself. So let's go ahead and divide both sides by negative 4. And then I end up with negative 16 divided by negative 4, which is positive 4 set equal to the square root of x. And we'll finish this off by raising both sides to the second power. Again, our goal here is to get rid of this radical symbol. So when I raise both sides to the second power, I get 4 squared, which is 16, set equal to the square root of x all squared, which is x. Therefore, x is equal to 16. But let's make sure that we check to verify that this works. So let's plug 16 in for x in our original equation. So what did we have here? Again, it was the square root of x minus 12. Plugging 16 in, though, I get the square root of 16 minus 12 set equal to 2 minus the square root of 16. Now, remember, we're trying to verify if the left side is equal to the right side. So let's simplify the left side and then simplify the right side and make sure they actually are equal to each other. So the square root of 16 minus 12 That's equivalent to the square root of 4, and we know that the square root of 4 is equal to 2. On the right side of the equation, I end up with 2 minus the square root of 16. The square root of 16 is equal to 4. That way we end up with a negative 2. Is 2 equal to negative 2? No, they aren't. So what does that say about the value of 16? The only solution that we logically found algebraically? Since that doesn't even work, we say no solution will work for our equation. Now let's consider another example. This example 4, as you copy it down, I'll explain that this is no different than a radical expression. We know that fractional exponents or rational exponents is another way of writing a radical expression. The denominator of a rational expression denotes our index. So we know that an exponent of 1/3 actually represents the cube root. But we'll actually leave this in rational exponent form for the convenience of when we want to get rid of it. So our first step in this case is very similar to any old radical expression or radical equation. We want to isolate the radical part. So what I'm going to do is subtract 5 from both sides, isolating my 3y plus 1, all raised to the 1/3, set equal to negative 5. Now remember, in the first example, we raised both sides to the second power to eliminate the radical. Now the radical represents the square root. In other words, something raised to the 1/2. In this case, we have the left side set to an exponent of 1/3. Now to cancel this 1/3, what I'm actually going to do is raise both sides to the third power. So I have an exponent of a 3 on the left side, and I'll raise the right side to the third power as well. See, what happens here is I'm using my exponent rule where I've got an expression of 3y plus 1 raised to the 1/3 raised to the third. Remember, a power raised to an exponent, what we do is multiply our exponents. So what is the product of 1/3 and 3? That would be 1. So the left side of my equation simplifies to 3y plus 1. On the right side, however, I've got negative 5 raised to the third. Remember, negative raised to an odd power is negative. And negative 5 times negative 5 times negative 5 gives us negative 125. Let's finish this off by isolating the variable completely. I'm going to subtract 1 from both sides, and I end up with 3y equals negative 126. We'll finish it off by dividing both sides by 3, and y is equal to negative 42. As always, we want to verify that this actually works. So let's check our solution of y equals negative 42 in our original equation. All right, so here we go. Let's plug negative 42 into our original equation. So I've got 3 times negative 42 plus 1, all raised to the 1/3 power, which we know represents the cube root, plus 5, and we are verifying if this is equal to 0. So let's simplify this left side. 3 times negative 42 gives me negative 126 plus the 1, again, all raised to the 1/3, plus the 5. We want to see if we end up with 0 in the long run. Negative 126 plus 1 is negative 125. And remember, this exponent of 1/3 denotes the cube root of negative 125. And what is the cube root of negative 125? That would be negative 5. When I combine negative 5 with 5, we do in fact get 0. So, our equation works. Therefore, x equals negative 42 is our final solution. Now, in example 5, we have an inequality. The way we solve radical inequalities is very similar to the way that we solved rational inequalities back in chapter 9. What we want to do is find boundary points on our number line to test the regions in each section to verify the interval for where the solutions exist. So, our starting point is to consider values that will make our radicand positive. Since I'm taking the square root of an expression involving x, I want to be sure that 3x minus 6 is positive. So here's my first step for finding boundary points on my number line. I want to make sure that 3x minus 6 is greater than or equal to 0. So that's step 1. Now let's solve this inequality to find my boundary point on my number line. I add 6 to both sides, and I get 3x is greater than or equal to 6. Dividing both sides by 3, I end up with x is greater than or equal to 2. So, my number line has now been broken up into values above 2 and values below 2. Now, the next step is going to be to solve the inequality involving the original inequality. So let me label this as step 2. The first thing I want to do in order to solve my original inequality is to isolate the radical, just as we do in a radical equation. So I'm going to bring this entire inequality over here. So I'm going to subtract 4 from both sides in my first step. That way I end up with the square root of 3x minus 6 is less than or equal to positive 3. Again, this is a result of subtracting 4 from both sides. Then what I want to do is raise both sides to the second power in order to eliminate my radical from the left side. So we end up with 3x minus 6 is less than or equal to 9. Now let's isolate the x completely, adding 6 to both sides. We end up with 3x is less than or equal to 15. Dividing both sides by 3, finally we end up with x is less than or equal to 5. So, our number line has now been broken up into values greater than 2 or less than 5. So step 3 is going to be testing the regions on the number line less than 2, between 2 and 5, and greater than 5. And remember, we're testing this in the inequality that square root of 3x minus 6 plus 4 is less than or equal to 7. So, let's test a value to the left of 2. How about 0? So if I test 0, I end up with 3 times 0 minus 6, which is 0 minus the 6, plus 4, less than or equal to 7. Since 0 minus 6 is the square root of negative 6, we can't go any further, since the square root of negative 6 cannot occur in the real number set. So we're just going to stop here and realize that the values to the left of 2 will not satisfy this inequality. Now let's test values between 2 and 5. Let's pick, say, 3. So I end up with the square root of 3 times 3, which is 9 minus 6, plus 4, which is less than or equal to 7. Again, to the left I end up with the square root of 3 plus 4. Since the square root of 3 is some sort of a decimal value between 1 and 2, since the square root of 4 is 2 and the square root of 1 is 1, I know that 1 point something plus 4 is certainly less than 7. So this region of my number line is satisfied for my original inequality. So I'm going to include negative 2 all the way up to 5. So these numbers do in fact work. The last step is to verify whether or not any numbers above 5 will satisfy this inequality. So let's test 6, a value to the right of 5 on the number line. So when I do that, I end up with 3 times 6, which is 18, minus 6 under the radical, plus a 4, less than or equal to 7. The square root of 18 minus 6 is equal to the square root of 12, plus 4 is less than or equal to 7. Again, without even having to reach for our calculator, we know that the square root of 12 is in between the square root of 16 and the square root of 9. Therefore, it's equal to 3 point something. 3 point something plus 4 is not less than or equal to 7. Therefore, all the values above 5 will actually make the left side of the inequality greater than 7. So, no values in this region of the number line will satisfy our original inequality of square root of 3x minus 6 plus 4 is less than or equal to 7. So, what we do in step 4 is finalize our final solution set based on our number line that we found. So what we'll do in order to represent an algebraic solution set is we'll say that 2 is less than or equal to x, which is less than or equal to 5. In other words, x is between 2 and 5, including 2 and 5. All right, folks, let's please make note that our homework tonight is page 266, numbers 4 to 22 even, as written on the sideboard. But I thought I'd put it here for you. And that concludes our lesson on solving radical equations and inequalities. Good luck!
Made with Doodlecast Pro.